X squared plus 2x minus 1 equals 0. A solution to the given equation is root k minus 1. What is the value of k? Okay, so right away, given the radical, we can suspect this is going to be an irrational solution. In fact, if we looked at minus 1, the factors of minus 1 that sum to plus 2, they don't exist. This is not factorable over the integers, which means we're only going to have irrational or non-real solutions or roots, and looks like we have irrational roots. So if I can't factor it, the first thing I'm going to go to is the quadratic formula, and it looks like this term's probably going to be the first term of the quadratic, and this is going to be my discriminant term simplified in the quadratic formula. But let's double check. So x equals the opposite of b over 2a, and I'll write them as separate terms. The square root of my discriminant, b squared minus 4ac over 2a, and minus b over 2a is going to be minus 2 over 2 times 1, the leading coefficient, which is not written, but it's still 1, even though not shown. That means x equals minus 2 over 2, or x equals minus 1. All right, that's great. That's exactly what we have in our given root or solution. Okay, so that's consistent. We now really need to figure out just this second term here. And we're obviously going to take only the minus case, not the plus case, given the sign. I take that back. We're only going to take the plus case, not the minus case, given the sign of the square root of k. Okay, so let's take a look. B squared here will be square root, my discriminant b squared is 2 squared minus 4 times a, which is 1, times c, which is minus 1. Okay, so I have a minus minus, so I'm going to add in the discriminant there. That's all over 2a, which is 2 times 1. Okay, so that's going to work out to simplifying the square root of 4 minus minus 4 is plus 4 over 2, which in turn is the square root of 8 over 2. And now I can simplify the square root of 8. The square root of 8 is really, if I factor it out, the square root of 4 times 2, which in multiplication we can break out the radicals to square root of 4 times square root of 2, which is 2 root 2. So I can replace that square root of 8 with 2 root 2. Now my 2's top to bottom cancel. And my solution on the second form here, the second term of the quadratic, is the square root of 2. So my entire solution or root is the square root of 2 minus 1. Given that, putting that over there, x equals the square root of 2 minus 1, which means k is simply going to be 2. 2 is the answer for number 33. K equals 2. C of x equals 5/9 quantity x minus 32. Well, I can distribute that right away. That's 5/9 x minus 5/9 times 32. And C is Celsius here. X represents Fahrenheit. If the temperature is increased by 19.8 degrees Fahrenheit, that is, X goes up 19.8, how much does the temperature in Celsius increase? Okay, well, I like to do a change on both sides of the equation. I'll note that as delta C equals 5/9 delta X. And note the delta of the constant, the numerical value, 5/9 times 32, is 0. It's a constant. By definition, the change of a constant is 0. So this leaves a pretty simple, straightforward change. Delta C equals 5/9 delta X. And we know what delta X is. That's the 19.8 degrees Fahrenheit increase. And I simply need to multiply this out to get delta C. So delta C equals 5/9 times 19.8. which if we run the calculator, it's going to be 11. The correct answer for 34 is 11. Now, there's another way to approach this. It might be more comfortable for most students. It takes a little longer, but simply look at the first temperature and then the second temperature, 19.8 degrees higher, and take the difference between them. So, for example, let's suppose I had C of, I don't know, let's make it 69.8 equals, and then I want the next one, which will be different by 19.8. I'm going to make this one lower. C of 50. That's a difference of 19.8 degrees in Fahrenheit, my x. So what does that mean for the numbers? It's going to be 5/9 times 69.8 minus 32. And at 50 degrees, it'll be 5/9 times 50 minus 32. And I could take the difference of these two equations, almost like we do in elimination. The change of Celsius, C, call it 1, if we call this equation 1 and this equation 2, C1 minus C2 equals 5/9 times 69.8 minus 32 equals 5/9, 50 minus 32. And I'll ultimately get essentially the same thing if I simplify it. 5/9 times 69.8 minus 50, which is our difference in 19.8. The 32 terms will cancel, and then I can go ahead and solve for that, and I'm going to get the same answer. The change or the difference in Celsius for the two equations is 11 if you run those numbers out. So whichever approach is more comfortable for you, I find this a lot faster to work with.